here. Okay. Where's my share? All right. Can you see my screen?
Yep.
All right. So I assume that's probably you on here. But
Yeah, I'm the other one on here, I guess.
yeah, I basically have kind of an intro paragraph of kind of what this is. Um, I kind of view it as two different but um, complementary concepts. One is the concept of just being able to describe the high level architecture of something. I don't think what we want to do, I don't think we want to recreate UML or anything like that. I think this is a little bit more abstract, a little bit more high level, but being able to describe how something is architected, whether that something is, a piece of software, um, a medical device, um, guidance system on fighter
Mhm.
jet, right? How something is architected, and then be able to describe how that thing should behave, as well as optionally being able to describe how it actually behaves. So you can actually capture the delta. Um, that's kind of how I've been describing it when I talk to others. Is that kind of your vision as well?
Yeah, no, I think this. Yeah, I was reading this because you posted it obviously a few days ago, and I looked over it. I think it's very nice and succinct because I think this is the phrase blueprint or the word blueprints actually makes a lot of sense in for exactly this. And I think this is something that's essential to understand what am I even working with? Hey, I got this piece of software. I mean, I have this device. What's expected of it? What components does it exist and how do those components interact? I think that this I don't know, this use case or concept brings that together.
Yeah. Well, we can credit Jeff Williams for the term blueprint. I don't know where he pulled it out from, but I agree. It kind of captures essentially what we want. I mean, if you look at just like the blueprints for, I don't know, a building, right? So
Yeah.
kind of like the same kind of thing that we're trying to do here, but for software and systems, which is interesting. Um, so in this document, we've got just some placeholders for use cases. And then what we typically do is once we kind of build out these use cases, we will then define what are the requirements in order to achieve said use cases. And once we actually have that, those two things, which I think we should, I don't think it'll be overly difficult because again, this document isn't really intended to boil the ocean, right? This is not some big long PRD or anything like that. Um, but just a set of use cases, set of basic requirements, just enough to kind of set us up so that we can actually start prototyping and playing with different ideas, is essentially what this provide is supposed to provide the foundation to kind of set us up for. Does that make sense? Is that a good path forward?
Yeah, I like that idea. I think that was one of the things that people kept talking about with SBOM in general. Like, okay, I have a thing. What do I do with this? And
Mm,
if you start at the baseline of, hey, here's the useful things you can do, it can
right,
help make sure you're including the things that you need to enable that.
right. So, um, use case one. I think the obvious one is just transparency, but I don't necessarily know if we need to. Well, I guess we should actually, because that actually is going to tie into one of the requirements. Um, so maybe use case one.
Hmm.
Now, I don't know if that's use case one or not.
Yeah,
That's kind of just rolled off stream of consciousness, honestly.
yeah. I I feel like there's a few different use cases in that,
Yeah.
right?
Just can be decomposed.
It can be
One, just the
decomposed.
transparency, right?
Yeah. Um, I mean, the one of the kind of the core reason I started even thinking about uh, software bills of behavior was the SolarWinds attack. Like that's kind of why we started dealing with this because that was a problem of hidden malicious behaviors in the thing that you already trusted.
Right.
And the things it started doing after like the bad update, well, hey, it waited 14 days and then started calling out to, you know, a Russian threat actor.
Right.
Um, if we knew that this update started calling out to places it never did before, that would have been really useful. So I think
Agreed.
that's a subset of this, right? It's like, hey, you want to defend
Yeah.
your organization, right?
Right.
But not necessarily defend the application.
True. That's true. That's true.
So I think part of this though is like you can defend the application from a vulnerability where it's like, hey, there's a vulnerability in this. If my application doesn't have the a behavior of calling out before and now it does, that's that's showing that, oh, maybe I got exploited. And
Right.
there's been code injection or whatever the underlying problem is.
That's essentially what we're trying to get to right here. As a
Right.
consumer, I need to defend my organization against unexpected behavior.
Right.
And in order to do that, I need to be transparent about the expected behavior.
Right. Right. You can't know what's unexpected if you don't know what is actually expected.
Right.
It's sort of a layer above application or maybe below application whitelisting. You're like, hey, these applications are allowed to do things, but what are they? What should they be allowed to do?
Yeah. You brought up the solar winds use case and or not use case, but scenario.
Right.
And I've been thinking of that about that a lot as well. And I believe I would love somebody to threat model this, but I believe with the recent addition of cryptographic assets in CycloneDX 1.6 and with the addition of bill behaviors in 1.7, I believe CycloneDX would actually be capable of being able to identify and possibly even with the right tools prevent a solar winds type attack. So um, that's going to be really interesting. I would love somebody to potentially threat model that. Maybe we can get somebody from the OWASP community or something volunteer to do that.
Yeah, that definitely be interesting because that's yeah, that again, that's exactly what it is. If someone knew, hey, these are the behaviors, you know, previous version to this version, now it's doing these weird things. Even if
Right.
even if SolarWinds said, hey, this is expected, at least I guess an end user would be able to say, but do I want that? Right. So maybe that's more of like this is back to being a consumer. You have the capability of doing more risk assessment that you wouldn't be able to do otherwise.
Correct.
And if it wasn't expected for them, then it's doing it, then it's a different problem, right?
Right.
Um,
Exactly. Um,
well, it's kind of like what was that thing? That antivirus vendor that had the crypto miner in it?
oh, right. Yeah.
That was
Yep.
intended though. Like that was completely intended by them. They wanted
Right.
to they wanted to allow crypto mining.
Right.
Uh,
Works as it's designed.
right, right. It works as it is designed, but the consumer maybe doesn't want that.
Yeah, exactly. Um, I'm thinking about, well, is there anything, let's just do the behaviors first and then we'll do the architecture use cases afterwards. What other behavior use cases do we have?
So let's see. So unexpected behaviors, like I think the opposite of that, you want to know what the expected behaviors are, if that makes sense.
Okay.
Because then say I I, I like giving examples because this makes it easier for me to think about it. Um, and this is something I remember hearing from somebody. Hey, Microsoft just, say Microsoft updates something, and now it's calling out to a new IP address. That's a new IP address that's never happened before, right? So if you understand what's expected for this update, now you're not going to get a bunch of false positives, from
Hmm.
your anomaly detection. Hey, I'm connecting out to an IP address I've never connected out to, or a domain or whatever. Um, but if that's
Right.
actually expected for it, that can help alleviate some of the defender, ding
Right.
fatigue or alert fatigue.
Um, okay. So I'm thinking of a scenario where, like you mentioned, the IP address. Well, if you get the update from the vendor and now they are calling out to a new IP and that is expected, well, now you could be able to read that bill of behaviors and dynamically like alter your firewall rules or whatever, right?
Right. Like, hey, I'm gonna open it up because this is the expected behavior. They're trusted. Maybe
Right.
maybe you have to have like structure around that to make sure it is actually intended, right?
Right.
Um,
And likewise, if an IP address is no longer needed,
mhm.
right? Now I can actually close it down.
Right. It's like, hey, I have this, chunk of the IPv4 space. Now I don't. I'm actually in
Right.
IPv. I'm in six now. So if I'm connected to any of those old IP addresses, why am I doing that? Or
Yep.
whatever the case may be. You don't want to keep that open if someone else now has control over those IPs.
Got it. That makes a lot of sense. I'm
Kind
just
of
going to
the
try to capture that. Okay. Anything else for behaviors?
so I don't know if this is necessarily be maybe it's a combination of behaviors and architecture. Um, but if you're consuming like a lot of like one of the other potential use cases is how is this going to change and is it going to break something? Because uh, I know this happens in like hospital systems where I don't want to update my medical device because if my I don't know CT scan goes down, like people can die, right?
Right.
So if you can predict how those behaviors are like going to change from one update to another, you can get a risk, maybe a risk tolerance. Like, hey, there's very few behaviors, maybe there's a lot of behaviors. Can we understand what that looks like? I think this is like maybe a subset of one, right, for unexpected behaviors, but it's subtly different, I think.
Yeah, I think this is this is almost like if you have, I'm almost seeing this as, it's a little bit different, but um, I think you can probably do it with like just one, but I'm in my mind, it's like, well, if you have different systems, both with different behaviors, right? And now one system, like its behavior is now using, I don't know, um, OAuth instead of SAML. Now I know that this thing is not going to talk to this thing anymore, right?
Right. That's why it's like sort of architecture, part behavior, right? Like, hey,
Right,
here's, this part of the architecture communicates to another part this way, or it communicates out to, I don't know, third parties or however you want to like think about the architecture, right?
right,
Which makes sense why blueprints actually makes a lot of sense. This potentially is well, it could be the internal parts of the blueprint not working together, but it could also be, since I'm stretching this analogy, hey, how do my sewage pipes work? How does my water coming in work, right? Or my
right.
electricity.
Okay, got it. All right. A lot of what we come up with in
Mhm.
these use cases and stuff like that, what we find is that have you seen our authoritative guides that we have for the specification?
I have
We
not yet.
Okay. We have, just to kind of um, um, show folks, we have some really well produced guides for different things. So, like, we've got one for SBOM, one for cryptography bill of material, one for attestations. The one for SBOM is in its second edition already, but pretty well produced,
Mhm.
and you'll see in here a lot of the use cases, and then we kind of expand upon a lot of those use cases and kind of drive down into a lot of best practices and that sort of thing. So whatever we come up with here, right, usually kind of feeds into the development of those guides, which is really good. Um, so if we can come up with some really good like scenarios, that'd be fantastic. Um, we actually did the last two feature working groups. What we ended up doing is, once we actually got the spec, once we actually got the spec and the examples that were compliant to that proposed spec, once we actually solidified those, the groups actually pivoted and actually started working on the guides. So that was really, really useful. For 1.6, we introduced support for cryptographic assets, CBOM, and we introduced support for attestations. And both of those feature working groups ultimately ended up creating the authoritative guides, because they were the ones that created the spec. So it made a lot of sense. So maybe we can do something like that here. Obviously, it's way too early to do that now, but just to give you an idea where some of this content might ultimately end up. Um, are there any other major use cases for behaviors other than what we've already captured?
Okay. I'm just trying to see like, yeah, like understand understand behaviors. Is it expected? Is it not expected? That's kind of like first two, like as I
Right,
guess as subsets of them, like validating that behavior, right? Those are just trying to think of like what other things.
right.
Is this
Yeah,
going to
I mean,
break stuff?
I think that's a valid one.
So a little bit more specific.
What's that?
I was just thinking, yeah, this is basically like it's not like defending, but it's like defects. So that makes sense.
Okay. Yeah. Yeah. Mm-hmm.
Is
Yep.
there are there reasons for wanting this kind of stuff on the like we're talking about like essentially consumers of the software. What are there use cases for people developing software?
Well, this use case right here
Is
is not necessarily about consuming.
yeah,
This could be on the consumption side,
right.
but it
It could
also
be
could be
either,
on the production side, right?
right?
That
It's
the
like,
system or application is behaving.
yeah. And and I guess in my head, also the consumers being happy with your software is sort of a use case for the developer, right? Like, hey, I'm not getting called because I changed like the domain. Like,
Right.
oh, or triggering false positives. Like that's probably pretty useful on the consumer side,
That's a
the
really
developer side, right?
interesting possible use case. Could behaviors, if we document the behaviors of something, could that potentially inform security tools that are testing like applications?
Yeah, I sort of saw that as like use case two.
Okay, okay. I need to
So I guess the subset of that, right? It's
yeah,
like
okay.
not just IPs though. I mean, that you could potentially get to the point of um like, hey, this thing is this 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 has the ability to create a reverse shell. It's like, oh, but that's SSH. Like, oh, that's what SSH does, right?
Right, right. Yeah, okay. No, that makes sense. That
So
makes
that's why I was
sense.
thinking on the consumer side, yeah, like informing not just network connectivity, but potentially like host IDSs or
Right,
antivirus EDR, whatever variant of defensive tool you're using.
right, right, right.
I think that's definitely
Uh,
part of it.
so how should I capture that? Um, writer's block.
So maybe like this is talking about network, so maybe like host-based behaviors. So host-based behaviors, um, like so I guess EDR is famous for this. They're basically rootkits,
Yep.
right? So if an EDR is expected to hook um all your system calls, that's expected, right? You don't want to get a false positive for that. SSH has the ability to connect out, right? And allow you to run commands on your machine. Like it basically can create a reverse shell. Yeah, it's the sort of thing where the way I usually think about it, there's no behavior a a computer can do that's inherently malicious. So if you can
Right.
come to understand what is expected for this, you can help reduce those false positives.
Got it. No, that makes a lot of sense. Okay. Uh,
And that helps both the person developing the software because then they're not getting called, hey, why is your stuff not working?
right.
And also the people using it to actually allow it to do the things it's supposed to do.
Any other use case for behaviors before we move on to architecture?
Um, I think that's kind of what I've been thinking about.
Okay.
Um, if you get malware now, and people who develop malware to give you the behaviors so you can block it, that would also be nice, but I doubt that's going to happen.
Right. Right, exactly.
If bad guys would just tell me the bad stuff they do so I could stop it, that would be a lot easier.
Right.
Please
Talk
tell me your
about a
entire architecture before you attack me. I need in CycloneDX 1.7 format the blueprint. Thank you.
oh, that would be funny. Yeah. Um,
I mean, what about you? Any other thoughts on this before we get into architecture?
no, I mean, I think the anomaly detection was like my number one thing. And a couple of these use cases kind of hit on that anomaly detection, right? Either from known good, known bad, um, from a testing perspective. So, um, oh, here's one maybe. How would that be used though? Okay. All right, all right. Um, this is kind of a this is kind of an this comes after, I guess. This comes after, I guess. So like if something is not behaving as expected, I can then document what I'm seeing
Mhm.
versus what they're seeing, and now I can communicate all that stuff back.
This is back to the point about capturing those deviations
Right,
from the act. Like here, this is what we actually saw occur.
right, right. So this is actually using both at the same time to inform essentially a manufacturer or, somebody with a kind of a need to know so they can kind of do some investigation.
Right? It's sort of like bug report-esque, right? But hopefully with, I guess, better formatting.
Right. Okay.
Yeah, definitely interesting for forensics.
Yeah. Something I know very little about, but from the outside in, it sounds fascinating.
Yeah, I've done a bit of like incident response stuff. So
Okay.
it's not it's not quite as like forensic-y as like, hey, I need to make sure I dot all the T's so I can go into
Right.
court, right? But
Right. Well, sometimes that happens depending on what
yeah,
agency you might be working for, but yeah.
right.
Um, okay, cool. I can't think of anything else for behaviors, honestly. Um,
Yeah, but the nice thing is this is a living document, so
right. You should have, let's see. Anyone that's linked can comment. Yes. Okay.
yeah, I can comment.
Okay.
But I figured why would I comment when you can type?
Because I'm dyslexic as hell and I really need to focus when I'm doing this. It's actually quite exhausting, actually. Um, it's taken me, I don't know, 20 years just to get to the point where I can semi spell and stuff like that. So it's
That's what spell check is for. So
Grammarly is my best friend, I'm telling you. Yep. Yep. I have it installed on my work machine, my all my personal machines. Yeah, seriously.
yeah, it's definitely nice having having someone be able to double check or having the machine double check for you, I guess.
Yeah. All right. Um, there are, I know, I'll have to reach out to Christopher Gates. I was on a, another thing that we're doing in 1.7 is, we've assembled the individuals who write the books. We've assembled the open source tools as well as the commercial vendors that support the threat modeling industry, both from a security and privacy perspective.
Mm.
So, we've basically got the entire threat modeling industry backing CycloneDX and kind of working towards making CycloneDX 1.7 have as kind of an interchange format between the tools, as well as being able to describe the threats and countermeasures and weaknesses, and even the diagrams of different threat models, regardless of what's, a Stride or Linden or Pasta, whatever, attack trees. So all that is coming. There might be a little bit of tie-in between architecture, how we do that, and some of the stuff that we're doing on threat modeling. There might be a little tie-in. We'll have to flesh that out a little bit. But Chris Gates has been over on the threat modeling working group. That group has met 3 times so far. And they're also scheduled to do every other week. But anyway, during the last call, which is also up on YouTube, he mentioned something about, and I'm not going to put words in his mouth, but it was something about medical devices and some kind of FDA requirement on like system architecture designs, which I thought was really, really interesting. So there might actually be like a compliance or regulatory aspect to architecture.
Yes, there is from the FDA. That's
Oh, there
relatively
is.
new.
Okay. Okay.
Um, I think it was either end of September or early October last year. The FDA like put into, I guess, effect. Hey, here's like
Uh,
the whole list of requirements. SBOM is in there.
Right.
Vulnerabilities. There's a couple additional things for SBOM beyond like the minimum elements.
Right. Right.
Um, but yeah, architecture. I think threat modeling is also, I don't know if it's technically a requirement or just a thing you need,
Nice to have.
nice to have. I don't, or need, I don't know. Requirement versus need to have versus like, because FDA regulations, sometimes they're very strong suggestions and sometimes they're
Right.
like strict requirements, right?
Right. Right. Yeah. Yeah.
So again, I'm not a regulator, so um,
Um,
I'm not going to speak for them. But yes, there's information about security architecture and how things interact with each other, and whether those, like network connectivity, is that encrypted? Because you should probably do that.
okay. Okay. Um, I don't think we want to. I don't think we want to reinvent the wheel here. There's some standards to describe architecture at various levels, and I think we should figure out which standards we should probably support, and how Cyclone DX could possibly provide a little bit more summary information, or more of an abstract type of architecture, I think would be really good. Because again, I mean, you can go down to the class level like UML, that sort of thing. There's obviously other standards for system architecture and stuff like that that get really detailed. But if I just want to describe, hey, I've got like these two medical devices in a patient room, and both of these things like communicate out to like the nurse's station. How can I just describe that as a basic type of thing in CycloneDX, and then refer the consumer of that CycloneDX to the more detailed information, right? Using one of the existing standards that exist. I don't think we want to recreate the wheel here, but I think that there's something in the middle that we could potentially provide.
Right. Well, especially if part of the idea behind the behaviors is the interconnectivity. So having that be like, hey, this is the, I don't know, this is the chunk of, I don't know, this is like one individual piece of the system, and this is how it communicates out. And like that's part of the system architecture, and how those interact brings back into in the behaviors.
So being able to tie the architecture with the behaviors of a thing that's in that architecture.
I think that's pretty essential for like this concept of blueprints, right?
I think so. Okay.
Because that is a lot of applications. Like as the consumer of this thing, you need to know how it works and how the pieces interact and how they're going to interact with each other and the outside world. Maybe yeah, each thing.
Yeah, I don't know what to call it yet.
Yeah,
Um,
which is fine.
each thing in the architecture should be able to reference zero or more behaviors. That's good. I know I'm skipping ahead here, but
Fine. We have 14 minutes until the end of our allotted time. So
yeah, yeah, yeah.
getting some things down is better than no things down.
Yeah, yeah, yeah. Um, okay. Chris Gates has been working with, I don't know what standard it is, but I know he's been working a lot with Eclipse Capella. I've never really used it before, but I guess he's been working a lot with this. I recently just installed it on my machine just to kind of play around with it. I haven't had a chance yet, but I'm gonna dive into that um, over like the next week or two. Um, might even reach out to Chris to see if he wants to kind of walk me through. Um, I haven't watched these videos and stuff yet, but um, yeah, I need to figure out there's this sets of standards, and there's a bunch of other things too that we could potentially integrate with. And then So I guess another requirement would be um, um, to integrate with the
You didn't mean
yes.
trademark bomb?
No, it's not a trademark bomb. I promise Google Docs, it's not. Every time I do that in Docs or Word or
Yeah.
whatever, it always just corrects it or tries to.
Right.
So we haven't kind of figured out like what are the assets that we're going to be doing for threat modeling, and in reality, those assets might ultimately be used in both threat modeling and architecture, right? If we can solve that and solve it for both use cases, that would be ideal. Because in threat modeling, we need to, obviously identify the assets
Hmm.
that we have in play that would ultimately need to protect, whether it's systems, data, people, whatever.
Right.
And if those could theoretically be part of our architecture, then win-win. Same with the optional diagrams. Not every threat model is going to have a diagram, but the ones that do, we should figure out how to potentially integrate with that. So I think there's some synergies between these two, but I think they're ultimately very, very complementary efforts.
Yeah, it makes sense because like understanding your architecture helps you understand what are my targets, right?
Right.
What are the things I need to protect?
And that ultimately leads into the concept of attack surface. So if you've got
Right,
the
exactly.
architecture and yeah, okay. Oh, that makes a lot of sense.
Right. And if one of your behaviors is I accept connections, right? That is definitely part of your attack surface.
Right.
Right. And this kind of gets into, I mean, what you mean by behavior, right? But depending on how low level you get, it kind of leads into like vex, right? Like, my behavior is to call this function in OpenSSL, and is that one of the vulnerable functions or not, right?
Right. Right.
But again, that seems like that's already kind of covered. But
Um,
but where do we link everything, right?
what's that?
Where everything once you're talking about systems, everything is connected, right?
Right. 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 Yeah. Um,
But yeah, attack surface and understanding that those potential interactions are key.
yeah. Okay. Um,
Yeah, that's yeah, this I really like this one because it's not just attack surface. Like we used to do some red team kind of offensive security stuff.
right.
So it's like if you have the architecture and you kind of know where the crown jewels are, or like the thing that an attacker might want to get to, you can kind of
Right.
think about paths through. Hey, what are the
Yep.
expected connectivity and what do I need to defend to make sure that attackers can't easily jump from one one section to another.
Mm-hmm. Yep. Any other use cases for architecture? I'm sure there are.
I mean, in some ways, I think it's maybe not subsets, but like additions to like the other use cases for the behaviors, where
Right.
it's like you need to understand what the architecture looks like, not just for regulatory or compliance, but the thing you were mentioning about was like, hey, these are patient monitors. They connect to the nurse's station. What is the expected, system architecture for this thing? How is it going to be used in practice? How does it need to be set up?
Right.
Set up configuration, whatever you think of there. This kind of gets back into what ports do I need to open? Ooh, especially if like we're thinking the system is part inside your network, part SaaS application, right?
Right. Does that make sense? I need to know the potential impact on the behavior of a process or system should one of the components in the architecture go down or have problems.
Oh, I mean, that wasn't exactly what I was thinking, but that is also incredibly important.
Right. Like if you've got multiple independent devices, right? But you have a business process that actually requires both of them to be operational,
Right.
right? What is the impact to that business process? Like, I don't know, a defibrillator, right? Maybe you have a defib
Yeah.
and something else, and those two things kind of work together in order to save a patient's life, right? Well, if one of
Right.
those things go down, what's the impact?
Yeah.
You
Yeah.
could probably apply this thing to an automobile as well, right?
Right.
If what is the potential impact of the behavior of the process should I don't know, my airbag, my front bumper detector, right, not function properly.
Right.
That would cause my airbags not to go off in the event of an accident, right?
Right.
Those types of things.
I mean, even something less dire. I'm thinking like Netflix had a Chaos Monkey
Right.
where we're just like, hey, I'm
Right.
going to kill this process, right? Because we need to be resilient. The same kind of thing.
Right.
Like,
Right.
how resilient is your system? Is the
Mm.
architecture?
Right. Yeah, I like that.
Yeah. So this is definitely more. Yeah. This definitely goes on the resilient side rather than normal operating system.
Okay, how do you spell resilient?
Re, I think it's IESIL. I don't know. ENT. I mean, now right click. No, no,
it's so bad. It's so bad. The spell check won't even work. Let's see. No residency. No, that's not what I want.
RES. Oh, I think there's an L. So it's RESIL.
Resilience.
Yeah, there it is.
Okay,
I did the exact same thing.
fantastic.
I Googled it. Because sometimes I can't spell out loud. I can type it, and then it'll be like, oh wait, my brain knows how to type this. My
Right,
subconscious, not my conscious, right?
right. Yeah,
Okay, that's good.
yeah.
Um,
That's a really important use case, I think.
yeah.
Resilience.
Um, I do need to drop off in two
Yep.
minutes.
All right, Andrew. Yeah, I think we're probably at a really good stopping point. I think in my opinion, we actually covered a lot. This is a lot more than what I actually thought to get to the day.
I've
So
thought about this before.
I know you have. So this is good. This is
I
good.
could send you the presentation I gave at a conference like a year ago, kind of on
Okay,
Billy behaviors. But
awesome.
yeah, I've thought about it.
Very good. Well, Andrew, I hope the rest of your Friday is uneventful, and have a great weekend.
All right, sounds
And
good.
yeah, talk to you soon.
All right, thanks,
Cheers.
Steve. Bye.
Bye. Bye.